Okay, so here we have that a man starts walking north at 6 feet per second from a point P. 10 minutes later, a woman starts walking south at 4 feet per second from a point 100 feet due east of P. At what rate are the people moving apart 15 minutes after the woman starts walking? Okay, so the first thing we need to do is to draw a picture and label everything. So here, let's say that the man is right here, and he's going to be walking north at 6 feet per second from a point P. So let's say this is P, and the man is going to be walking north. And 10 minutes later, a woman starts walking south at 4 feet per second from a point 100 feet east of P. So if P is right here, 100 feet east of P, well, let's just say that that's right here. And so the woman is going to be going down and so let me label this. So the point from P to the woman, this is going to be 100 feet. Okay, so now the issue is, well, we need to label all this stuff. So here, 6 feet per second is for the man. So why don't we call the distance the man walks, we're going to call M. And the distance the woman walks, let's call that W. So if M is the distance the male walks, then 6 feet per second, this is going to be the derivative of M with respect to time, because it's telling me how fast M is changing. Okay, so I can write this down. The derivative of M with respect to time is going to equal 6. Okay, and then that means that this 4 feet per second, this is going to be the derivative of W with respect to time. So that means the derivative of W with respect to time is equal to 4. Okay. And so the question is, at what rate are the people moving apart 15 minutes after the woman starts walking? Here, this part where it says 15 minutes after the woman starts walking, this is our when. So at what rate are the people moving apart? Well, I have to find the distance between them. And so let me label that. So if the male is here, the woman is here. So I need to draw a line. And let's call the distance between them D. So that means that what I'm looking for is the derivative of capital D with respect to time when 15 minutes after the woman starts walking. So let's say when the woman has been walking for 15 minutes. And I'm going to put it in words because I don't quite know what to call this, because the man and the woman start at different times. So we'll take care of that later. So okay, so I labeled everything, and a lot of this makes sense, but now I need to figure out a way to relate all of this information. Okay, so once I've labeled everything, I need a formula that relates all of the information that I have. So here, well, notice that You can look at this as two triangles if you want, but it's probably better if instead of looking at it as two triangles, you look at it as one big triangle where the horizontal distance is always 100, and then if you look at this, the height of this triangle is going to be m plus w, the distance the male has walked plus the distance the woman has walked. Okay, so notice that we can relate all of these by the Pythagorean theorem. This means that d squared is equal to m plus w squared plus 100 squared. Okay, and well, let's take a look to see if I have all my information. Well, this is 100 is constant, so I don't worry about that. M and W, I don't have M and W specifically, but I do know how fast they're going, so I could find them. So why don't I get the derivative of both sides? And so I'm going to rewrite my equation. Okay, so I'm going to get the derivative of both sides with respect to time. And so what I have is, well, remember that d is a function of time, so I have to use the chain rule. So what I'm going to have is 2 times d times the derivative of d with respect to time is equal to, here with m plus w, I have to also use the chain rule. So I'm going to have 2 times m plus w times the derivative of the inside. Well, the derivative of the inside is, the derivative of m is the derivative of m with respect to time plus the derivative of w with respect to time by the chain rule. And then the derivative of 100 is just 0. So I don't worry about that one. Okay, so then I take a look here and I ask myself, okay, do I have all of these pieces of information? Well, D I don't have, but I should be able to find it. M I also don't have, but I can find it. W I don't have, but I can find it. These two I have. Dm over dt, that's just 6. dw over dt, that's just 4. Okay, so I have a little work to do. I need to find m, w, and d. Okay, so I need to find m, w, and d. Okay, so now to find m, w, and d, well, I need to use this information here. I know that here you have to be a little bit careful because the man and the woman started walking at different times. So notice that the woman started walking 10 minutes after the man, and we want to know the rate that people are moving apart 15 minutes after the woman starts. So the man is going to walk for 25 minutes while the woman walks for 15 minutes. Okay, so using that, well, I know how fast they're going. So if the man is going 6 feet per second and he's walking for 25 minutes, well, then that means that I just need to figure it out. So the man is going to walk for 25 minutes. Now here you have to be careful because it's in you have to be careful with your units because the rate is in feet per second. So I need to turn 25 minutes into seconds. So remember that 60 seconds is 1 minute. So I can convert it by multiplying by 60 because the minutes are going to cancel. And I'm going to multiply this by 6 feet per second. And notice that after this, all of my my units, the only one that's left over is feet. And so this tells me that it's correct. Okay, so if I multiply 25 times 60 times 6, I'm going to get that the man walked 9,000 feet. Okay, if I apply the same reasoning for the woman, well, she walked for 15 minutes. Convert those into seconds. And then multiply by the rate that the woman walks at, which is 4 feet per second. And again, the minutes cancel with the minutes, the seconds with the seconds, and what we get when we multiply 15 times 60 times 4 is 3,600 feet. Okay, and D is going to equal, if we look back here at our formula, well, that's just going to equal the square root of m plus w squared. So this is going to be, if we add m plus w, this is 12,600 squared plus 100 squared. And this is equal to approximately 12,600.397. Okay, so that means we can plug all of this stuff in. We can plug in for D 12,600.397. For M we can plug in 9,000. For W we can plug in 3,600. And when we do all of that and solve for D, derivative of D with respect to time, this is going to equal 2 times 9,000 plus 3,600, that's 12,600, times 6 plus 4 is going to be 10, divided by 2 times 12,600.397, and this is equal to approximately very, very, very close to 10. And it's 10 feet per second. And that's it.